Hi everyone. Today's video may be a little bit longer. This is page 806. We're going to do 5, 18, 23AB, 30, 32, 43, 49, 50, and 61. Feel free to jump around to whatever problems you need. Okay, so starting off with 5, we are just asked to find the dot product of A and B. So this should be very straightforward. A is 4, 1, 1/4, and B is 6, -3, -8, and if we take the dot product A dot B, we've got 4 times 6, 24, 1 times -3 is -3, and 1/4 times -8 is -2, and so 24 minus 5 gives us a solution of 19. So our dot product there is 19. All right, next we'll look at 18. 18 is asking us to find the angle between two vectors. A is the vector 4, 0, 2, and B is the vector 2, -1, 0. So we're going to use A dot B equals magnitude A, magnitude B, cosine theta. We'll solve for theta. So A dot B, let's compute that quickly. 8, 0, 0. So, okay, 8. Magnitude of A is going to be, let's see, root 16 plus 4, so root 20. And magnitude B is going to be root 4 plus 1, or root 5. And that's then times cosine of theta. So we've got, that's convenient. So that's going to be 10. So we've got 8 equals 10 cosine theta, or 4/5 equals cosine theta. We'll do inverse cosine of 4/5, and we end up with an answer of 36.87 degrees. 36.87 degrees. That's the angle between those two vectors. And that's it. Okay, good. Next is number 23, A and B. Okay, determine whether the given vectors are orthogonal, parallel, or neither. I'm going to start with A. So vector A is -5, 3, 7, and vector B is 6, -8, 2. Let's take the dot product. So that's -30 minus 24 plus 14. And that is not equal to 0. Don't care what it is. And therefore, they are not orthogonal. They are also not scalar multiples of each other, right? So because it's not equal to 0, we know they're not orthogonal. Remember, orthogonal means perpendicular. A is not a scalar multiple of B. So A does not equal, we'll say some scalar times B. So they're also not parallel. And so therefore, this case is a neither. They are neither parallel nor perpendicular. B, we've got the vector A, which is 4, 6, and the vector B, which is -3, 2. I have a sense these might be perpendicular. So 4 times -3 is -12, plus 6 times 2 is 12. That gives us 0. Therefore, these are perpendicular. Oh, sorry, the book wants us to use the term orthogonal, but same difference. Okay, next up is 32. Okay, so we've got y equals sine x and y equals cosine x. And it says, find the acute angles between the curves at their points of intersection. The angle between two curves is the angle between their tangent lines at the point of intersection. Okay, so let's first talk about the first intersection. When is sine equal to cosine? That's at pi over 4. So the point is going to be pi over 4, comma, root 2 over 2. That's where the two curves intersect. So we want to figure out the slope of the tangent line at that point. So we're going to take y prime, which is cosine x, y prime here, negative sine x. And let's take y prime at pi over 4, which is root 2 over 2, and y prime at pi over 4 for this one, which is negative root 2 over 2. Okay, so what this means is that the slopes are those two values, but we're going to turn those into vectors. So I'm going to say vector u, just treat this as rise over run, right? The rise numbers in the denominator, the rise numbers in the numerator, the run numbers in the denominator. So 2 comma root 2. Think of that y over x is going to match that. And then vector v, we're just going to say is 2 comma negative root 2. Okay, now the work from here is to just use u dot v equals magnitude u, magnitude v, cosine theta. So let's go to the calculator and we will get an answer that way. I'm going to show you some calculator work with defining the vectors. So vector u is defined as 2 comma root 2, and vector v defined as 2 and negative root 2. Good. So let's take the dot product of u and v, which is 2, and let's take the magnitude of u times the magnitude of v. That gets us 6. So what we have here is that cosine theta equals 1/3. So we're going to take the inverse cosine of 1/3, and that gets us a acute angle of 70.53. Yes. So theta is 70.53. I just did all the computation on the calculator for there. Okay, what's next after 32? We've got 43 and 49. Okay, 43. All right, so this one says find the scalar and vector projections of B onto A. All right, so we're going to find the projection of B onto A, which is B dot A over A dot A times A. That's the vector projection. Then we're going to find the scalar projection of B onto A, which is B dot A over magnitude of A. All right, let me just adjust my work here real quick. Okay. All right, so in 43, vector A is 2, negative 1, 4, and vector B is 0, 1, 1/2. So our numerator here, B dot A, is negative 1 plus 2, which is 1, and A dot A is 4 plus 1, 5, 16, 21, I believe. Yep. So it's 1 over 21 times the vector A, 2, negative 1, 4. You can leave it as like that if you like, or write it as 2 over 21, negative 1 over 21, and 4 over 21. Oops, should be a 1. Okay, so that is the vector projection of B onto A. And now we're going to figure out the scalar projection. So same thing in the numerator, 1 over, and then magnitude of A is going to be root 21. Okay, so that is the scalar projection of B onto A. 49 is next. Find the work done by a force, which is 8, negative 6, 9, that moves an object from the point 0, 10, 8 to 6, 12, 20. All right, so the displacement vector then is the vector from the first point to the second, or 6 to 12. So work is F dot D, which is 48 minus 12 plus, brain fart, 108. And 48 minus 12 plus 108 is 144. The units on it would be Newton meters or joules. Okay, next up we have 50 and 61. Okay, 50. A sled is pulled along a level path through snow by a rope. A 30-pound force acting at an angle of 40 degrees above the horizontal. Okay, so 30 degrees above the horizontal. The force is 30 pounds, so we're not using newtons and meters here. Moves the sled 80 feet, so this thing is going 80 feet there. Okay, so work this time we're not going to do F dot D, we're going to do magnitude of F, magnitude of D, and then the cosine of theta. So the magnitude of the force is 30, the displacement is 80, and the cosine of 30 is root 3 over 2. So we've got 2400 root 3 over 2, or 1200 root 3. And those would be actually foot-pounds, which is another measure of work. Okay. Oh, I just did 51. Oops. Okay, let's do 50. Sorry, that was actually 51. My mistake. Oh, very similar. Okay, so it's going to be same type of work. The magnitude of the force is 1500. The distance it goes is 1,000 meters. We got to be in meters, not kilometers. And then the cosine of 30. It's basically the same problem. So that's going to give us 15 is a root 3 over 2. So that's going to give us 75,000 root 3 joules. There it is. And then 61. 61 is a proof. It's a really cool problem. Use theorem 3 to prove the Cauchy-Schwarz inequality, which is that the absolute value of A dot B is always less than or equal to magnitude of A times magnitude of B. So we're going to try and prove that. So the way we do that, and let's just start with this statement. Theorem 3, right? A dot B equals the magnitude of A times the magnitude of B times the cosine of theta. All right, let's take the absolute value of both sides. So that's the absolute value of A dot B equals, we don't need to bother with putting the absolute value symbols around the magnitudes because those are positive by definition. We'll just put it around the cosine theta. Okay, and then since the absolute value of cosine theta is always less than or equal to 1, then we know that this statement is always less than or equal to magnitude of A times magnitude of B alone, right? Because if absolute value of cosine theta is less than or equal to 1, then that's going to shrink that whole statement down. So we can say then that the magnitude of A dot B is less than or equal to magnitude of A times magnitude of B. Okay, that proves the statement. I'll take questions in class, and I also want to return to last time's assignment in class too, because we forgot to do that.